Okay, so now we are saying for today's video, we're just to okay, it's fine, madam. Are you there?
Yes, I'm here. I'm just copying the question.
Okay, just copy. Oh, we have Mr. Myron. Mr. Myron, how are you? Mr. Myron. Okay, so this is the question we are dealing with. We are saying a 4 centimeter high object is placed 8 centimeters from a convex lens of focal length 3 centimeter. Okay, draw a scale diagram to find the position and size of the object. Now here there's no big deal here. So what will happen is that we are told that this object is 8 centimeters from the convex. Now when you use your rule, you find that, let's say, if we start from this guy here. Okay, sorry, that's dropped. So let's say if you start from this guy here, okay? Let's say, for instance, if this is our 8 here, okay? So copy the question first before I display something.
I'm done copying, sir.
Okay, you're done copying. Mr. Myron?
Yeah.
Mr. Myron?
I think maybe he's on mute or something.
Let me check him. Let me check for him. Participant. What is he doing on mute? This one. He doesn't know how to use it. So.
I'm not sure.
Okay, let's move on. Now we are told that this thing actually is it is 4 centimeter high object is placed 8 centimeters from the convex. So now when you check here, mathematically we know that 2 boxes actually is 2 centimeters, or 1 box is 2 centimeters. So it means 1, 2, 3. Let me use a pointer. So let's say, for instance, if you start from here, are you able to see my pointer?
Yes, I can see.
So let's say, for instance, if start at 0, this is 1, 2, 3, 4, 5, 6, 7. So let's place it another again. Let's say we start from here. We set 1, this one, 2, 3, 4, 5, 6, 7, 8. Okay? Or if you don't want like that, you can just get your rule. You measure, maybe let's say from here, you measure from here or anywhere, you measure your 8 centimeters. Okay?
Okay.
So now let's say if my 8 centimeters is here, so meaning my object is somewhere, they are not.
Yes, sir.
So meaning by showing to say, let me use a beautiful ink. Okay, let me use a yellow. So meaning this is for instance, this is the convex lens. Okay, so meaning your object is somewhere here. Okay, so meaning if your object is somewhere here, so what will happen, you even draw the down part like so. Okay, then from there they have said what is the length of this. They have said this object, it should be what length? It should be 4. So meaning you from here on this line, you measure a 4. You measure a 4 there. So now what will happen is, after measuring a 4, you even indicate that this is the object. Then on the tip of this, you draw a straight line. Okay? You draw a straight line. So what will happen is that when you draw a straight line, you even indicate the arrow. So on the tip of this arrow, you come straight. Okay. Now they have said the focal length is what? It is the focal length is it is on 3, right? So when you measure, maybe let's say your 3 is here. When you measure from 0, this is the 0 point here. This is the 0 point. This one here, this yellow thing you have seen there, it is the convex lens. It is the convex lens. Yes. So from the convex lens, you measure the 3. From here, you measure your 3. So let's say, for instance, if your 3 is here, okay? Your 3 centimeters, of course. Use a rule, you measure. Use a rule, you measure. Maybe your 3 centimeters is here. Oh, sorry, I've even lost the line. Okay, so maybe your 3 is here. Are you able to see where I'm putting my 3?
Yes, sir, I can see it.
So your 3 is there. Okay, so now you don't indicate 3, no, but you put what you call F to show them that you are dealing with what? A focal point. Yes, of course, you can call it the focal length, but in this case, it's called a focal point.
Okay, sir.
Is it okay?
Yes, sir.
So what will happen is that immediately when this line here, which is coming from the object, it passes through the focal point. You have seen?
Yes, sir.
Is it okay?
Yes, sir, it is okay.
So now, what will happen again from here? Let me point it. Are you able to see from here, this pointer? You're able to see the pointer there?
Yes,
from this point here, you draw a line passing through the center, passing through this center here, the center here. Are you able to see the center?
Yes, I can see it. Okay.
So what will happen is that you draw a line passing through that point. You find that now you should be using a rule when drawing from this point here. From this point here to that point, you draw using a rule. From this point to the focal point, you draw using the rule. Also now, from this point to through the horizon up to that side, you draw using what? A rule. Is it okay? Yes.
Yes, sir.
So what will happen, let's say for instance, because this is not drawn to scale, this object is not drawn to scale. So what will happen, let's say for instance, you have seen, where these two lines, these two lines are meeting, you draw on top. You draw on top there. So this one. So let me show you. Just a minute.
Okay, sir.
Let me suggest these things. Let me move this thing. So from this question, let me keep it. So remember, from that point of view, we had such kind of a scenario. Okay. This one is the object. It was 4 centimeters, if you remember. Then the distance from here to there, it was 8. Using a rule, it was 8. It was 8 centimeters.
8 centimeters.
It was 8 centimeters. Then this is the object there. Then we were told that the distance from here to the focal point, this is the focal point, okay? It was 3 centimeters. Yes. So what will happen was you draw like so, okay? You draw like so, using a rule. You use a rule. Now, be careful. Look here. The easier way of you to find this kind of a scenario is like so. You just measure also. Since this guy here is 4 centimeters, they are not so. This guy here. This guy here is 4 centimeters. Also here, just measure from here to there. Put a 4 centimeter there. Okay? When you put a 4 centimeter here from here to there, put a 4 centimeter here. But do not indicate. Do not indicate. so that you just join them like so using a row. You have seen, eh?
Yes, sir.
From there now, you drop it direct. The focal point, you have seen the point of the focal point is passing through the focal point.
Yes, the focal point.
Yes. So what will happen is that if we draw a line, again, you come here on the tip of this, then you draw a line passing through the center. Like so. This one's supposed to pass through the center. Using a rule. So you have seen the physics?
Yes, sir.
Okay. So now, this is your object. This is your object there. So where these two have met, this part where they have met, you draw it like so. So what have you done? That is your object. That's your image. That's the image. Please do not force them to meet. Do not force them to meet. At times, they don't meet. They end up meeting from this side. They end up meeting from this side. So meaning the image is not real. If they meet from this side, it means the image is not real. But when they meet in this manner, the image is real. Okay? Is it okay?
Yes, sir, it is.
Okay. Now, from there now, I hope it was drawn. Let me go back. You see it?
Yes, sir.
Now,
I have the diagram.
Yes. What will happen is, let's say, for instance, if they ask you to say, calculate the image. If they ask you to say, calculate the image. Okay? Oh, sorry.
Yes.
Measure the image. How do you measure the image? How do you measure? You just bring your rule. You measure from this point. Let me show you. You measure from this point to where they are meeting. So this one. From your diagram, which I've already drawn, what is the length of this image?
Let me get the rule. Let me get the rule, sir.
Okay. So you're not drawing using a rule.
It is 2.7.
Yes, so it was 2.7 centimeters.
Yes.
So now, if you're asked now to find the magnification, so magnification, the way we calculate for magnification, mag is equal to the length, length of image, the length of the image. What has happened? The length of image the length of image over length of object. Length of object. Don't worry, that's how we'll be moving.
Okay, sir.
Don't worry, just that the space is minimal. Okay. So now, remember, that's the way we calculate for magnification. So now, on the next scenario, we will now indicate, okay? We say magnification, we found that it was 2.7 centimeters.
2.7 centimeters.
Then the length of the object was already given, not so?
4 centimeters, yes.
Yes. So what will happen that these centimeters, they will cancel, okay?
Okay.
So now when you punch on the calculator, what is the answer? 0. What? 0.5 what? When you punch on the calculator.
That's a minute, sir.
Okay. Don't worry, I'm using the...
Given as 0.675.
0.675. Now, when you check here, these centimeters, they have cancelled. It means that magnification has no what? Has no units. So you can just say time. You can just say x there, or you can put it like so: x 0.75. So that's how we calculate for magnification. That's how.
So that's the answer.
Yes, that's the answer for magnification. Now let's go back to the question. Let's go back to the question. Okay, let's go back to the question. Don't worry.
Sir, sorry, just 1 minute. Let me get my daughter. She's just crying.
Oh, yes,
just 1 minute.
No problem.
Just 1 minute.
No problem. Don't worry. So now from here, earlier we did this part, not so. Madam Caro, you are ready?
Hello.
So
now, sir.
Earlier we did this part, right? We said, let's say for instance, we said, now when you check on this question here, they want the size, okay? So it means that from the angle's perspective, we have already calculated for the size. So it means you say 7 centimeters. Yes.
7 centimeters.
Then what it means by when they say position, like in this scenario, they want position from here. They want the position of the image. Now remember, let me do this. Okay. Okay, don't worry. This is the goal. Now, from aerially perspective, it means that when they ask you to say what is the position, it means that let's say for instance, we had such kind of a scenario. We had the object there, it went through like so, not so. Then it went like so, right?
Yes.
Then we had such kind of a scenario. So it met somewhere here, not so. So now it means you measure from the origin to where it is. So from the origin to where it is. So you measure from this part to there. So this is the distance they wanted. So what was the distance?
Sir, you measure from the upper 4 centimeter to the down one.
No.
One.
Look here.
Yes.
Look here. Listen.
Yes.
We said in that scenario it was like so. So it was moving like so. Okay. So it was like so, not so. So they met somewhere here. So when you say position, you remember that there's this guy which is the convex lens.
Convex lens.
Yes. So it means you measure from the convex lens. The convex lens is this one. So if this image is here, not you measure from here to there, from here to there. This distance, you can see it.
Yes, I can see now.
This distance from here to there, where it is like that.
Okay.
So that marks the end of our today's lecture.
Thank you so much.
Hey, it's very simple. So you have seen that online is nice. It's nice.
Assignment.
Eh?
Give us the assignment, guys.
Yes, let me give you the assignment. The assignment is here. So today's video, the assignment is this one. This is the assignment here. Don't worry. This is the assignment. So you can just screenshot the assignment.
Okay.
Hope you're able to see.
Question 6. Question 6?
Yes, question 6. We are saying figure 6.1 shows a ray of light in the instant ray. So that's a glass. So meaning there's you do. I won't say much. You do. Yes. You're able to see?
Yes. I can see. I've already screenshotted.
Okay. All the best of luck.
Thank you. So I'll submit the other week.
Okay, you should submit. Yes.
Okay, sir. Thank you.
Mr. Myron, you are there? Myron ni bagona Myron. Swazi vote unmute Myron.